Hey guys, welcome back to another episode of the Grinder Build series. Last week we tracked down Tim and Hayden in their secret locations and got a little bit of a look into the design of, or the importance of power and weight from Tim, plus the importance of the parallel, design of the machinery and the chemicals and the tooling and how important it is that they all keep up with each other. And then Hayden actually revealed to us the new 22 kilowatt permanent magnet motor, which was a pretty sleek bit of kit. Today I'll be catching up with Tim and Hayden again, and I'm told we're going to be seeing some new stuff, but they haven't really told me what we're seeing. So I'm really excited to see what they've been working on. I think it's going to be exciting. Got a bit of an idea of what it might be. So let's head on over and see what it is exactly that they've been working so hard at. Let's go, guys. Come on. Okay, this is not what I was anticipating seeing. I thought, what's going on here, guys? I was told that we were going to be seeing the wheels today.
Yeah, I did agree to show you the wheels. So, it's there's a whole lot more to it than just the wheels, but I can show you do you want to see the wheels?
Well, last week we talked about the motor, we talked about horsepower, and then you told me that we were going to be talking about the wheels, and so I thought, well, surely we've got the motor, we've got the wheels, we're ready to go.
Did I tell you what wheels I was showing? I just said the wheels, didn't I? It's about the wheels. All right, I'll cut you some slack. I'll show you the wheel.
You can see the wheels.
You happy? You've seen the wheel?
What's going on here? What have you guys been working on?
Well, like I said, it's not just about the wheel. There's a whole lot more behind the wheel that matters more.
Enlighten me. I'm sorry, guys. I thought I was going to be showing. I thought we were going to be showing the wheels this week.
All right. We thought we'd just be talking about the really important stuff.
Yeah.
It's a good thing Tim's not on a mic. All right, then enlighten me. We've seen a motor and now we've seen some wheels.
Some wheels.
And we've got 3 machines here, so let's get the ball rolling. Tell me about, well, there's more to it than just wheels.
Well, there is. There's a whole lot to it. The geometry of a machine, which is based around the head.
The geometry of the wheel has not changed. It's
Still a circle?
Yeah.
So's the head. 2 circles next to each other, there's problems, all right?
All right, okay. Now I'm all ears. Tell me.
Well, obviously we've got 3 machines here that, different manufacturers. There's big parts around how far is a wheel from a head. That has a whole lot to do with how's the machine going to react? What's it going to do? How's it going to get around a pole? How's it going to tip back? There's a whole pile of stuff that this affects. And it's all things that we have to think about.
Okay. How big of a job is it?
To change the wheels?
Well, you said it's a lot to think about. And if I have a look across these models here, and this is only a really small selection, I see similarities in these 2 machines, but then I see a completely different wheel size on the machine over there. And then now that I'm looking at it, I'm seeing different orientation. What does it all equate to? How do you decide? What are you looking at? What is important here?
All of it's important. The head size, so the larger the diameter of the head, effectively the further back the wheels have to become to get next to it. So obviously you've got gaps in the sides here between here, and as you bring the wheels closer, the closer you get to the head, the wider they have to become to get them close. And there's a real balance between how close you want them to the head and how far they need to be away from everything else around them.
Hence, on some machines, you've got the larger machines got really wide gap in there, and it's really easy to get access for the hoses. And then the narrow machines, we start having difficulties with the packaging of the wheels and the motors, and then trying to get dust extraction out the back as well.
That's right.
Yeah, okay, all right. So this is getting a little bit more complex than I was anticipating.
More than just wheels, right?
Yeah, well, It's the now in me. So we've got the packaging of that particular part of it, the relationship between the head and now the width of the wheels. I can understand that, but why do I care about how wide it gets?
How wide it gets, as in the wheels?
Yeah.
Well, I mean, if the wheels are sticking out past the machine, do you like doing edge work by hand?
Well, I'd get pretty annoyed because the machines that the cover's in line with the wheels, or the wheel sits out slightly, you always have to recorrect along the walls.
Correct.
And then when you want to work around columns and stuff like that, it's just, I mean, I'm getting really picky here because I'm operating with a radio control, the joystick, and my thumb's getting worn out having to correct and stuff around columns and that kind of thing, corners and that. And I'm looking at you both like you've already thought about this.
Maybe.
All right.
If you're thinking about it, I'm sure we've already thought of it.
Well, why don't I just stand back and you guys just tell us the whole thought process. I know that this part of the project took a long time.
Correct.
So why don't I just sit back and you guys start from the beginning of the project on the wheels, and I'll just listen up and get educated.
Sounds good. All right, Tim, so tell us, where do we begin?
Well, I guess really to understand the modern day radio control machine where essentially all the wheels are doing the work for the operator, we first need to understand a little bit what it was like beforehand. And the former propulsion method of a machine was obviously what we call a push machine.
Yes, I remember this all too well.
So every grinding machine, as the discs are working on the floor, has a torque or a purchase as those discs and those abrasives are actually doing some work. And the grinding head naturally wants to pull to one direction or to one side when it's doing that work and when it's engaged with the floor. So of course, in the old days when they were just push machines, the way to control that sideways pull or to combat it was through the chassis. And of course, the operator would have a set of handlebars on a lever like this, and you essentially had a pivot point, which was the wheels on the ground. So to control that sideways pull took effort from the operator. So the longer the lever from the centre of the wheels to the end of the handlebars, the better the leverage or the better the control the operator had over the actual machine. And of course, the second lever in the system was the measurement from the centre of the wheel to the centre of the grinding head. The shorter that lever is, the easier it was to control the machine, and the shorter this lever needed to be. So that was from controlling the machine as it's interacting with the floor, as it's passing across the floor doing the work. Those levers were obviously very important too in the old school machines from a manual handling. So because the machines need to be tipped back to access the tools and change them, the longer this lever was and the shorter this lever was, the easier it became to tip a machine back. Like such. And of course, the other thing was, when running the machine and controlling the machine, the longer the lever from the handlebars to the centre of the wheels, the easier it was to create fine adjustment and movements of the machine, because it's a reverse leverage pivot point. Okay, so it meant high control from a finessing of the machine, whether it be along walls, whether it be around columns, controlling ridges and so forth on the floor. But they're all the key lever geometries that were important in a push machine. And of course, now when we start talking about operator assisted machines where we've got radio controls and wheel drives, we no longer have a human as the anchor, a human creating the movement of the machine, whether it be the turning it around at the end of the runs, in corners, around columns, or just doing those finesse movements. We're relying on the wheels being the anchor point and doing all that for us. Right. So let's talk a little bit about how we transfer the old school importances of those levers
across to the newer machines.
across to a new machine.
Sounds good. So Tim, now we're looking at the newer generation remote machines. They all still have handlebars. Can't we just get rid of it?
Can't we get rid of it? People like handlebars.
For what purpose?
Well, I guess the handlebars are still required for tipping the machines back. So essentially from a dead weight point of view, machines haven't progressed very much.
Yep.
They've actually got heavier. We've talked a little bit about power to weight ratios and grinding power last discussion.
Yep.
We're seeing the machines actually get heavier. You've got bigger motors. We're now, seeing 15 kilowatt motors on machines and
22s.
And 22s. And so we're making machines heavier, but we still need to get to the diamond tools.
Yep.
The actual mechanisms for tipping machines back to actually accessing those diamond tools hasn't changed that much. So we still need the handlebar to tip the machine back. But obviously, if there is a wheel drive breakdown issue of some sort, most of the machines have a way of releasing the gearboxes and letting the wheels turn freely.
Yep.
So we can still run the machine as a manual or a push machine, okay?
Okay. So what I'm hearing is everything we just spoke about on the push machine is 100% relevant on these still.
Well, you still need to have it in, because in the case where you do need to use it as a push machine, you still want all those levers suitable for the push machine application. Otherwise, it's going to be a long day on the tools.
Yep.
Actually, a longer day on the tools maybe than some of the older machines, if you've got to use one of the newer machines
As a
in a push mode.
That's correct. All right, well, I guess, let's delve into a couple of the finer points. So we've already spoken about the distance between the front and the back. Now, that obviously plays in on an RC in a big way because you don't have the anchor anymore. So all the load the operator was taking before is now being borne by the two wheels and whatever weight's on them.
Yep. So in the past, the wheels were a pivot point and also an anchor point to stop the machine sliding sideways.
Yep.
But all the counterbalancing torsion through the chassis was leveraged by the operator off the handlebars.
Yep.
Now everything, your wheels are your anchor point for stopping the machine sliding sideways.
Yep.
They're the propulsion mechanism to move it forward and back over the floor. And they also have to be able to have enough purchase and grip on the ground to be able to turn that machine, move it from side to side,
When under
swing
load.
it around,
Yep.
load and unload the whole lot.
Okay.
So that brings a lot of different things into the equation when coming up with a wheel drive setup,
Yep.
which we're not talking about today.
That's right.
But when it comes to choosing wheels and where those wheels are positioned and how far they are from the head, they're all really important implications.
Okay. Because again, like we've been saying, if everything's now going through the wheels with a lot of the manufacturers, you'll see there's different issues that come up from pulling too much current through wheel drives. And that's not necessarily because of the wheel drive itself. That's the amount of load going onto them, which is that distance again. The further that is, the more leverage it has to push onto those wheels, which means more power the wheels need to combat that and keep it stable, which then leads into burning out plugs, gearboxes, parts being broken, shafts, things like that. So when you start seeing gearbox issues and electrical issues in your wheel drives, that's usually because of the amount of leverage the head has over that central system at that point. So definitely, again, as we've been looking at the push, how far away that is really critical around that.
Yeah, and we've got some good examples here within these machines that have quite different distances in that key lever we were talking about before. So we can see in this HTC at 100 over here, if this is our midpoint over here and our midpoint of our wheel, you can see that's actually a really long lever in this machine. It's evidenced by the amount of space you can actually see, the clearance between the actual side of the grinding head cover and the front of the wheel. Makes it really nice to be able to get your hands in there and do things, but it puts a lot of extra load on your drivetrain. And really ups the requirements of what the drivetrain needs to be able to do to resist that.
That's right. It also allows for a lot of this going on at the front as well, because any wheel drive is going to have clearances in pins and things, so everything has to be removable. It's not a solid mount, so everything's got movement, and the further forward you go with that, the more movement you have of that swaying effect on the grinding head.
So you're talking about play in the wheel drive systems, which we're not talking about today.
No, that's right. But in the existing ones, we have a lot of stuff in there that does, that distance affects that in a big way.
And that distance also, we're talking about the length of the handlebar in a push machine really being the ability to give you fine finesse, side-to-side movement, etc., through the machine. Obviously, the longer that leverage point becomes in a self-driven machine, it's going to amplify whatever the wheels are doing. So a small amount of movement in the wheel on a long lever is going to make the machine a lot twitchier than if those wheels are really close into the head. If that's all we changed, we kept the same wheel drive rotational controls, but we really shorten up that lever as much as we can. The machine becomes a lot less twitchy,
a lot more stable.
And the impact of a small change in rotation will only have a minor impact on the side-to-side movement of the head compared to as that distance from the centre of that grinding head to the centre of the wheel gets longer.
I mean, I'm sitting here looking forwards, and I think I've been in cars that are smaller than this length at the end of the day. It's a long way out the front. I'm going to have to get new glasses for that machine. Now, Tim, I mean, it's obviously we talk about all the movements up here and everything else. The wheels along the side. Now, you got how far in the wheels come, which we've spoken about how close you can get them. There's a lot of physical dimensions that can limit that around how close you can go. Also, head sizes are going to change that. If you've got an 800 head, you're not quite going to get as far up, or you may get closer, depending on how wide your chassis is as well. So you've got a head width, a chassis width, and a wheel width that all plays into it, which in turn also starts talking about how far back is everything else beyond the back of the wheels, because that's geometry of what's going on as well. So, what can you tell us about that?
Well, you're talking about cars before, and you've been in cars that are shorter, and we all know what it's like to do a U-turn and turning circles of cars and getting into tight car parking spaces. Job sites are no different, really. You can be down, you can be in small pokey rooms. You can be trying to turn around in a corridor. All of those sorts of things, how long the machine is from front to back and what's behind those central pivot points on the wheels is going to really impact how easy it is to turn a machine around, how convenient it's going to be able to turn it around or manoeuvre it in a tight space. So maybe we should have a look at some of these geometry on these machines and just have a look. We've got two machines here which are in that sort of 650, 680 size. Very different chassis, even when the handlebars are packed and stowed away in RC mode. But maybe we should run the tape measure over these and just see two different manufacturers, essentially the same size machines, but very different chassis lengths overall, because it's not just about the distance from the head, centre of the head to the centre of the wheels, it's what's hanging out the back of the machine too, right?
That's right. Sounds good. All right, let's get them out. All right, so what are we looking at?
Well, we've taken this 690 and we've essentially set it up in its most, let's call it the most compact position that would be available in grinding mode. So let's measure from the front of the machine to the sort of the maximum back.
So look, we're somewhere around about 1.2, just over 1.2 metres.
About 1200 mil. Okay. So that's for a mid-sized grinding machine. 1200 from front to back. I would say that's reasonably compact for a machine this size. Let's compare it to the Scan Maskin, which we have here as well. Clearly a very different chassis idea from the manufacturers, and let's just see how that stacks up within the actual overall size and dimensions. Probably one thing that is another really important dimension thing that we like to think about is how close a machine can get to the wall. And I'm just thinking about right now, it's pretty obvious with this weight kit down. The weight kit just falls just inside the cover of this machine. So as far as being able to get that grinding head underneath anything with these weights down in this position, makes it very difficult to get the side of the machine underneath anything. So
that's correct.
Clearance, or what we'd call inboard clearance from the side of the cover to where the next obstacle is, is something that is another geometric property that's important to us.
And obviously once the weights are backwards as well, we've got a similar thing with the turning circle hanging out the back, which is always a problem.
Yes, if it needs to be run with the weights back.
Correct.
That'll then extend it. We can work that out as well. Run the tape measure over that again. So in the hopefully unlikely case where we do need to run the machine with the weights fully back and we're working down corridors or in small rooms, we've now extended the machine from 1200 out to roughly...
It's about 1450.
So about an extra 250 mil in length, just by having to... Because we've got to get those weights in a different position.
Correct.
Yep. Cool. All right, Hayden, what are we looking at here?
A much bigger machine.
Bigger machine?
Look at it.
It's a lot of machine.
It's a lot. Well, I mean, the first thing I'm seeing is obviously our wheels and our cover are, very much in line, similar to what the 690 was. They're not in that far at all.
So you're talking about the outside of the wheel, how far inboard that is?
Correct.
From the edge of the cover. What does that assist us with? The closer we can get those wheels together, or the further inboard?
A lot of it is around obviously heading down walls, getting around obstacles. If the wheels are sticking out quite far, when you come around a corner and try and just duck around the edge of that pole, there's a wheel right there. In some of the manufacturers, wheel pins are sticking out, things like that. So things you can catch on a lot easier. Whereas if your head has a lot more space, you can just nudge it into a corner a lot easier and bring it back out without actually having to push the machine hard across.
Yeah.
Other big one is if you're reversing down a hallway or something and that wheel is there, you're readjusting constantly and having to drive back and forth.
So a lot of experienced operators will know when they've ground down a wall into a corner, they're going to back the machine out. The closer that wheel is to the wall, the harder it is to get an arc to back that machine out of there.
Correct.
Sometimes you actually got to lift the actual wheel sideways just to get it away from the wall to make that easier. So the closer we can get that wheel in, the better it is for even a really highly common sort of manoeuvring scenario like backing out of a corner along a wall, where you literally can't steer the machine any further that way because you're going to go through the wall, and any movement away from the wall is actually going to make that wheel track in and get stuck up against the wall. Yep.
And I mean, I'm seeing a lot of overhang at the rear on this one.
Yeah, so this machine clearly has a much more backward rake on the chassis, which is interesting because there's so much space here. Okay.
Yes.
But let's just run the tape measure from front to back. Let's forget that the jockey wheel's down because this one actually folds up out of the way. Yep. But so I'm pretty much at the back.
We're about 1550.
About 1550. Okay, so that's about 300 longer than the 690 was.
Yeah.
That's a big difference for a machine in the same size class.
It is.
So that's going to create some creative thinking when we're working in a compact room or in a hallway or something like that, or manoeuvring. Not to mention the space it's going to take up in the car.
In the van.
Or in the van or the truck. Yep. Just that extra space out the back.
Correct.
So quite a difference in overall length of the complete machine.
Yep.
One thing I do like about this machine, though, we were talking about inboard clearance. You can see the distance from here to here. There's actually more of this machine that we can poke underneath something.
That's right, under a bench or things like that.
So if hand grinding is not your thing, maybe you'd be gravitating a little bit towards this more machine than the other one, because it's going to take that little bit more work away from you.
It is, absolutely. So Tim, I don't want to say this is in a class of its own, but it's not in the same class as what we've just been looking at, right?
No, this is an HTC 800, so this is what you'd say is the next size up machine. So we're not really doing a size for size comparison, but we'll bring an 820 in just for a bit of a benchmark sort of comparison, because we are changing the size. And what we mean by that is because we've changed size, the head's bigger, so we literally can't have the wheels, as close to the centre of the motor as we do in a smaller machine, because we've just got a bigger diameter bowl to be working around, right?
Yep. Well, I guess let's see how it compares.
So probably two things I'm keen to measure on this machine. There's the front to back measurement, which we've been talking about in its most compact state, but then there's this dimension from the middle of the wheel to the middle of the motor, because I think we're going to see quite a difference between this machine and some of the other ones, including the 820 we're going to have a look at in a moment.
Sounds good. All All right, so we're probably in the vicinity of about 1450.
1450. Okay, so from memory, the 690 was about 1200. Okay, 1450, what, 250 mil, but it's a bigger class machine. So it's an 800, so it's got about 75 mil more distance on the front because of the bigger bowl. So we're going to discount the 75 mil because it's a bigger class machine. But what you're essentially telling me is this is from front to back in its most compact grinding position. This is measuring the same sort of size as that Scan-Maskin 32-inch or 650 or 700,
right.
whatever it is. Yep. So bigger class machine. So we'd assume bigger productivity, but same size.
Same size.
So interesting consideration for the purchaser when they're looking at these machines, going, well, this is a bigger machine. It's got more. I think it's a 15 kilowatt motor.
Yep.
I've got 800 millimeters of width. I've got 1200 mil of, or 1250, whatever it was, from front to back. So similar to a 690 in front to back geometry.
Yep.
But I'm actually getting
a bigger powerhouse.
more productivity.
That's right. Yeah, so storing in the van, this is not far off what the 690 was to put in your van, but you've got that extra productivity.
And our measurement from the centre of the wheel to the centre of the motor, that's a really important lever for
Around
an RC machine.
600?
Yeah, 630, something like that.
Yeah, somewhere, about 610,
Okay.
I can see.
All right, Hayden, final candidate for today. What are we looking at?
820 RC.
821 RC.
820.
Gen 1?
Gen 1.
Gen 1, not Gen 2?
Gen 2, no. 830 is a Gen 2.
830 is a Gen 2. I'm glad,
Same size, but different.
glad we clarified that. All right, let's run the tape the same as we have with the other
Sounds good.
machines. So once again, set up in the most sort of compact grinding position we've got. That's about the back of the emergency stop button there.
Yep, so around about 1442, so just under 1450.
1450 was the HCC 800.
Yep,
So
similar.
front to back measurement. Yep. The all important wheel arm, wheel to motor arm length.
So
How does
there
that
we
come
are,
in?
around about 460, or 455, 460.
Yeah, okay, so about call it 460 mil, and on the 800 it was 630.
610,
610, something like
it was.
So that's a huge difference in that arm
idea.
length from wheel to the, let's call it the centre of the torque position of the machine.
Yep.
So that's going to have some big benefits when it comes to controlling the
Absolutely.
head, when it comes to fine finesse control from side to side with the wheel drives through the radio control.
Plus how much load's going onto your wheels, skidding wheels and traction issues. So
Yep. And of course, the inboard clearance from the side of the chassis to the arm in this machine is quite big compared to the other
it is.
3 machines I've been looking at. So lots of options there for getting under things if that's necessary.
A lot less hand grinding.
What does hand grinding?
That's right.
All right, well, that was a lot of info. So run me through the key elements again, Hayden.
The key elements of what we spoke about, or what we're aiming for? What's
Well-
our ambition?
Both.
Well, obviously the ambition is everything we've spoken about here is a consideration that we put into it. There's a whole lot of other parts that get built around it that we have to consider, but yeah, certainly trying to tick all the boxes of the agility of it, getting around poles, all that kind of stuff, tipping back. There's more than just wheels, so it is a lot to work with. On not just on one machine, on different size machines are different in each of these categories as well. So
similar types of considerations. I'm assuming you go, the different size machines that we're bringing out, you want to try and keep, I guess, a fairly similar design queue around all of those as well. So that's all got to be consistent against all of the different products as well. Well, talk about just putting layer on top of layer.
that's right.
I'm glad that these guys are the ones that are having to work it out. Otherwise,
Well, it's all about picking and choosing your trade-offs at the end of the day. I mean, hopefully the viewers can see, even just from that brief look at those different machines, every manufacturer is confronted by the same problem to solve. There's trade-offs, and everyone's making those trade-offs and they're basing them on different priorities. I guess our job is to understand those trade-offs and those factors as well as possible and integrate them as much as we can to the best of our ability into the product that we're making.
well, thanks guys. Speaking of trade-offs, I reckon let's stop making videos and get you guys back on the task so that pretty soon we can be seeing the wheels. Thanks, guys. See you in the next episode.